In this week, I try to fine-tune the BERT based on the Twitter data we cover and label. First is we read the data and then we try to pre-processing. Because the BERT model have a specific format that we need to tokenize. So first is we tokenize the data and then we try to build the label as our target, and then we compare our input tokenizer and our target, and then build the data set. Then after we build the tokenizer, and then we build the data set about the training data set and valid data set. Then we use the pre-trained model. We import the pre-trained model, and then we start to, we setting arguments, and then we start to training. Our results show that we have overfitting because our training loss is very small and our validation loss is almost the same. And our accuracy is about 58%. So I think we can find more data or try to find some regularization or add some layer to fine-tune our model, to build our model to let our result be more better.
Yeah, so for me this week, what I did is I tried using the same Twitter label data set that we created. I started with decision tree. In this case, I used the TF-IDF, the count vectorizer followed by the TF-IDF transformer. And it's simply because I kind of want to package everything into sort of like a pipeline like this. It's also something that is more friendly if we want to bring the training to Google Cloud, but there shouldn't be any difference since we're doing this locally. But basically the idea is I apply TF-IDF vectorization on the reviews text and then use sklearn multi-output classifier. So this one is kind of like a wrapper on top of whatever normal classification algorithms that we use. So in this case, I use decision tree classifier. I also try doing a little bit of grid search, not on the decision tree, but more on the vectorization. So I try changing the max term frequency, the max features, the n-grams, and see if there's any difference, and try running it. So yeah, so this is basically where I run the grid search. But the results I got, I think this is pretty, yeah, so it gives me the kind of output that is best, and then I try to feed it back and run the predictions. And so I think in this case, the F1 score and the AUC score is a bit lower than the BERT that we saw just now, but seems pretty decent. The second approach that I tried is to still use decision tree classifier, but in this case, instead of using a bag of words approach, I would use a word embeddings approach. So this one is basically just using the GenSim and the NLTK package. I still create a bag of tokens, so I still tokenize all the reviews. But the only difference is instead of doing TF-IDF vectorizations, I kind of train a word-to-vec model on all the tokenized reviews, and then subsequently using this full model to convert all the tokenized reviews into word embeddings. And then the results for what I see is they seem to be quite comparable to the bag of words approach. So I don't see a large difference in terms of accuracy score or the F1 or the AUC compared to the bag of words. I think across all these approaches, it seems like the model that we train seems to be doing the best. So slightly higher in terms of accuracy and AUC compared to the GenSim pre-trained models, but not too different. So I think for me, the next step would be to try using other classification algorithms. So I tried decision tree in this notebook. So perhaps for the next one, I would try random forest or yeah, like the gradient boosting classifier.